It's free beer session, and then want to welcome Joe. Can Joe see us? No, he's in a
Yes, I
glass
can.
box. It's Joe's from MongoDB. He's gonna give us a presentation now, and afterwards we're gonna welcome an esteemed friend, ex-colleague, and alumni of Obsidian. Um, how do you pronounce your name? Willie, but I don't want to rub him the wrong way, so we'll just stick to Willie Engelbrecht from Hortonworks. And yes, I hope you guys enjoy tonight. Thank you very much. Joe,
Yeah,
can you please start?
there you go. That's what I needed. I couldn't hear you guys. Sorry. Okay, let me
Just
share
voices
my
in your head.
screen. Let me share my screen. Okay, you should be able to see the opening page of my deck, Event Sourcing, the best ubiquitous design pattern you've never heard of. Can everybody see that? Maybe drop a chat message if you can see that, and I will carry on then. Okay. Thanks for the introduction, even though I didn't hear any of it because you muted. My name is Joe Dragul. As you said, I'm Director of Developer Advocacy for EMEA, and that means I'm here to help developers become successful with MongoDB. And I'm going to talk today about event sourcing. And event sourcing has been around for quite a while, but it's surprising a number of people who haven't heard of it or haven't come across it. So I wanted to give you a little bit of the history, explain the structure and how event sourcing works, and talk a little bit about how you might be able to use event sourcing in your own applications and how it changes the way you think about how you build databases and data storage for your applications. So it's not a new idea, right? Event sourcing has been around since the 1400s, right? This guy is Luca Pacioli. And Luca Pacioli invented double entry accounting in Tuscany in Italy. And double entry accounting is the original event source. Double entry accounting is how we've done all accounting since Luca invented it in the 1400s. And effectively what double entry accounting says is we're only going to append entries to an accounting record. We're never going to erase anything. And any errors we make, we're going to address by effectively putting in new entries to address those errors. Let me just see if somebody's poking me here and says they can hear it. So this has been around, and double entry accounting is at the base of every accounting system we ever use. Its real joy is in a properly maintained double entry accounting system. Of course, everything balances to zero, and that's how you know you've got no errors. Your credits and your debits effectively you can calculate together to give you a zero sum. If, on the other hand, there is, I'm getting a message in here. I can full screen. Yes, I can full screen my PowerPoint. Sometimes that doesn't work, so I try not to do it, but I can do that. How's that? That good? Sharing is paused. Bring your shared window to the front. Can everybody see this in full screen mode?
No.
Okay. Let me just stop sharing and share the full screen version. Give me a second there. Now, everybody should be able to see it in full screen mode now. If you can't, Angela, just drop me a chat. So event sourcing is not a new idea. Luca Pacioli set it up. Hold on, let's see what she's saying. Okay, yay, good. We've got something. Great. Event sourcing is not a new idea. It's been around for a long time. And the beauty of it is you rectify errors by adding new entries to the log. And this is what made it so powerful, particularly when people are adding entries into a ledger manually, right? When you're adding entries into a ledger manually, it's very easy to make an error in transcription. Funnily enough, pretty much all the errors in every database you've ever seen were made at some point by somebody transcribing data from one system to another. So this was a big idea. And you can draw a straight line from event sourcing to modern blockchain deployments. Blockchain is effectively a giant event source. It is effectively all the transactions linked together in a mutable log. So we've been doing this for a long time, right? And it's not just for modern databases. Our relational friends love it. The log in a relational database is effectively an event source of all the write operations inside the database. So the idea of the log file is if you lose the data file, you can replay the log file to regenerate the state of your data. So this is a fundamental component that we're using right now today, even though we probably don't realize it in our relational databases. And we do the same thing in MongoDB. MongoDB keeps copies of data by producing what's called a replica set. So we do all of our writes to a primary node. That primary node is replicated to secondary nodes through a replication log called the operations log. And the operations log is, you guessed it, an event source. It's effectively an immutable log of all of the writes that happen on the primary that can be replayed idempotently on the secondary to produce a secondary, which is effectively an identical replica of the primary. That means in the event that the primary fails, the secondary can take over in what's called an election, and that election happens seamlessly. So this stuff is all around us once we start scratching the surface. So I want you to think about something trivial, file backup, and think about how we might transform a file backup system through a various set of steps. So the most trivial file backup we do is, and I used to do this a lot when I was younger, you take a zip file or a floppy disk or an external drive, and you drag a folder of files and you dump them into the backup disk. And there you go, you got a copy of all your data and it's safe. The problem with that kind of backup is, of course, you can't tell the relationship between the files on your hard disk and the files in your copy. And of course, if there's thousands of them, as there often are, if you're like me and you're a bit of a maven and you keep all your files, it's very hard to reconcile the data in your backup with the data in your source disk. So you do what I do, which is you put that disk away, you get a brand new external disk, and you drag all the files again. And that's kind of wasteful in terms of backup storage, but it means I absolutely know that on the date that I created this disk, the data was as it was on the source disk. Well, that kind of trivial backup is good as far as it goes, but that kind of reconciliation gets really old when you're trying to do it for thousands of files or lots of computers. So what most people finally do is they go, I'm going to use a backup tool, right? And you can use the crappy backup tool that comes with Windows, or the even crappier one that comes with Macs, or you can buy one. But the whole point of a backup tool is to give you an event source, a record of all of the copy events from the source to the target system, so that effectively it tracks. It doesn't keep the data itself, or it may not, but the point is it's not just the backup files themselves, it's a record of all the transactions, the source file and the target file. And now you can use that event source database to reconstruct your system at any point in time. And that's how standard system-to-system backup tools work. They have this event source inside, and it's generally stored in a database. What if we're a SaaS backup company? And I built one of these in 2002. So if you're a SaaS backup company, then what you've got to be able to do is back up all the files from all of the systems, right? And that is a big job. And you can think about it trivially as taking copies of files from lots of different target systems and taking them all to one big file backup system in the cloud. And when Amazon launched S3 about nearly 12 years ago, more than that, 14 years ago, it was the perfect place to keep all of these files. And you would keep an audit record of the source and the targets, and that would give you a way to reconstruct all of the systems that you have on your target system. Right. Well, real SaaS backup companies don't actually do that. What they actually do is slice the file up into tiny pieces, probably less than 16 megabytes, less than 10 megabytes. And they slice the files up and they send them up one at a time. And why do they do this? Well, if you're backing up a video file or a very high resolution photograph or indeed a database file, you don't want to have to restart every time the connection drops when you're halfway through copying the whole file. So the client takes a snapshot of the file and uploads it piece by piece and keeps the state of the events, the blocks that are getting uploaded, on the server. So effectively, if a file is interrupted, we can take that file and effectively find out what its state is on the server and start recovery from the point at which we wrote the last successful block. And so what we store in modern backup systems is effectively the blocks for the files rather than the files themselves. Why is this a good thing? One, we can reconstruct any file from its set of blocks. But two, when I have a copy of Indiana Jones and the Temple of Doom on DVD on my hard disk, and you have the same file, well, we don't need to copy the blocks twice because the blocks are checksummed. And so all I have to do is update the references to the set of blocks. And this, of course, leads to a very large reduction in the amount of data you need to store to back up all the world's files. And of course, then you can start to compress it. So what you're creating is an event source of all the files that you're backing up. And that event source represents all the blocks that are uploaded, and they're tagged with the files that are associated with. And that is what real SaaS backup companies do. So event sourcing is happening all around us, everywhere we look. Where else is this useful? Well, if you think about Uber and Amazon, they want to have an event source of all the key events. Uber and the other, effectively taxi app companies don't just have a single transaction. Think about the way taxi companies used to run. You only had one state: in a fare, not in a fare, got paid, didn't get paid. And the state of your business was defined by the total number of fares you took that day and the amount of money at the end of the day. Well, Uber and My Taxi and whatever your favorite local taxi and ride sharing services doesn't keep that. It keeps an enormous amount of data: how long people are waiting for cabs, where they get cabs, their affinity for picking up cabs at different locations, how long they spend in the cab, how much they tip, how do they pay. And that source of information, that event source that represents the total state of Uber and My Taxi's business, means they can mine and understand their business and ask sensible questions of their business much more easily than a traditional taxi business, which just had purchases and effectively, fares that were sold. The same thing happens in Amazon and other e-commerce businesses. Understanding not just the state of your basket right now, but how it got there. So effectively, everything you put in and took out of your basket, everything you stored, everything you bought, everything you didn't buy, becomes absolutely critical to Amazon running its business effectively. Because of course, if you're carrying items in your basket, there's a propensity to buy. And if you're effectively taking things out of your basket, you're either got them somewhere else, and Amazon sure as hell wants to know why you're buying stuff on other sites other than Amazon, or you've chosen not to buy at that time. And of course, Amazon can use this data to target you with better advertising or better offers, and also do analytics. What is the propensity for a certain class of user or cohort of user to buy or not buy certain things at certain times of the year? So storing the total state of everything that goes into and out of your basket becomes very useful. And this is a key learning for event sourcing. If you only store the current and some point previous state of the large domain objects, such as your e-commerce basket, it becomes impossible for the business to ask interesting questions because you've thrown away the data that might be useful. If you don't have the event state of the e-commerce basket in all of its ways and means, it's impossible for the business to come along and say, well, what was our biggest non-selling but put in a basket item in the last 6 months? Well, if you don't have the basket state, you can't answer those questions. And increasingly, what you'll discover is event sourcing gives you the ability to answer new and novel questions about the state of your business because you have a much richer picture of what's happening in the business that you're in. And why now? Why is event sourcing so it's emerging as a technology after 10 years. Well, I always remember the quote from, I think it's Peter Drucker, you know, what's the most interesting innovative technology? Well, it's the stuff we've been doing badly for the last 10 years, and we've finally got to the point where we improved it, where it's useful. The cloud computing allows us to store everything forever now. You can attach EC2 node to Amazon and host the EBS drive backed by S3 and store anything you want, every event in the business, every IoT event, every e-commerce event, every user event, every session event. All of these things can be used and stored in the cloud. So that's one thing. The second thing is you can compute at scale now. You know, running large compute clusters in Amazon is no longer a problem, or Azure or Google, or indeed in your own data centers. The ability to both run large compute clusters and do deep analysis on that large data set is now possible with, you know, machine learning tools, with Hadoop, with MongoDB. These allow you to get much deeper insights in near real time. So we see lots of our customers storing all of their session data, all of their customer data in MongoDB, doing recommendation analysis in Hadoop, and storing the results back in MongoDB, so that effectively you can do that kind of people like you bought stuff like this. And the reason we're able to do all this today is because the price of compute and storage has dropped to cents on the dollar. When I started building a startup for online backup in 2006, the price per gigabyte for stable storage, which is to say storage which has 3 stable copies of all of the data, was running at about $10 to $15 a gigabyte a month. Amazon launched in 2006 and took that price from $15 a gigabyte to 15 cents a gigabyte, and it's got cheaper since then. And that's transformed the industry in terms of what we can store and how much we can store, because you actually can store everything forever. So what's in the box? What do we get when we talk about event sourcing? What are the key things you want to see that tells you you've got an event sourcing system that's going to be of some utility to you? Well, an immutable append-only log. And you can draw a straight line from this back to Luca Pacioli and his event source, or go forward to, of course, the best immutable append-only log in the world, blockchain. We don't need to deploy all of the cryptographic security for blockchain for most of our event sourcing applications, because, of course, most of these applications are controlled and managed behind our own firewalls. But the reason you want it immutable is because it means you can't change history. And it's exactly the model of the double entry accounting. You could never go back in a double entry accounting book and erase history. If you erased an entry, it was considered a massive error. So you only ever append it. And it turns out immutable append-only logs are the best way to get the most performance out of modern database systems. Almost all modern database systems are based on a copy-on-write model. And if you're only updating a tiny field in a row in a relational database or a part of a document, well, with copy on write, we have to move that whole document to the end of the database. And that's an expensive transaction. It's a read and a write. When you're only appending transactions, well, all of modern database technologies, MongoDB included, have storage engines which are designed to optimize appending to your database. So you get higher performance, and of course, you get all the data, and you can tell and know that anything that's happened in the past happened in the past and is not being changed. And of course, when you have an event source that runs back for 10 years or 20 years, if you're like me and you've been with the same bank account since you left college, obviously we don't want to have to total up all my credits and debits to get to my current balance. So of course, what we do is we take key snapshots of the data we're interested in, the total number of credits and debits, the total basket value, the current basket value, the total number of open bookings on Uber, plus the total number of all bookings that have been closed and sold. And those snapshots mean that we only have to go from the snapshot to the current point in time to get the current state. So effectively, you only need to look back in time to the last snapshot. And of course, over time, you're going to discover you need different snapshots to answer different business questions. And in that situation, then you run a compute cluster to effectively roll up your state in parallel. And that is an ideal role for MapReduce, which we can do in both MongoDB and Hadoop, for those of you that like Hadoop or Spark. So this essentially gives you the ability to have this very rich event source, which is effectively unindexed and, you know, as fast to write as we can. And then we separately keep a kind of an indexed store of snapshots that we can query in a more reasonable way. And think of it just like your bank account. Your bank account doesn't actually total up all of your transactions. It keeps a snapshot of your balances and then uses that balance to add new transactions to the end. But where do these events come from? What constitutes an event? Well, domain-driven design talks about business events originating commands. And in this case, it's commands that change the state of business objects. So you want to think of events not in terms of the updates to fields in objects in your application. You want to build your application around a set of command objects that change state in terms of moving you through a workflow. So if you think about, you know, flight bookings, you want to start with, you know, check bookings, look to book, then pick a flight, then pick a time, then pick a price, then make a payment, and then effectively either issue the boarding pass, or you might change the flight later. But effectively, all those events, not all of those events are going to lead to a final booking, but they give you very interesting information about who is spending time on your website looking at your flights. And so commands become the business objects that change state. Aggregates are effectively the collected objects that represent the state of an event at some point in time, and they consist of aggregates and values themselves. So an aggregate is effectively a roll-up of some set of state of some set of objects. So some example snapshot queries we might generate. You know, what purchase orders failed to get approved in Q2? Well, we definitely want to know about purchase orders that failed to get approved, because that represents lost opportunities in the business, or, you know, we've made some decisions to change the model so that purchase orders that were previously approved aren't getting approved now. So often the finance department will ask to reduce the spend in travel and put a gate on travel prices. What cabs get billed more than $50 a journey? Every cab sharing and ride sharing company in the world wants to know who the big spenders are. Which cabs get the biggest tips? The biggest tips are generally the drivers with the best customer service and the best customer money. How many baskets have had $200 for 2 weeks or more? Well, any e-commerce vendor wants to know people who are carrying a desire to buy something and not closing on it. Maybe these are the people that want free shipping. Or which sensor events exceeded the safety threshold on 21st of July 2016? That's the day in which we had an amber event in our manufacturing plant, and we wanted to see which sensor events might have led us to determine and find out about that before it actually happened. And all of this originates from a programming language called Eiffel. And it was invented by a French man called Bertrand Meyer, and he came up with this model called command query segregation. So we only have two types of objects. We have command objects, which change state, and we have query objects that only return the read-only state of an object. And he said, if you can build your application out of just command objects and query objects, you'll be able to prove its correctness more easily, and it will be more correct and easier to manage and maintain. And that begat in Microsoft this thing CQRS, Command Query Responsibility Segregation. And a guy called Udi Dahan came up with this model, which effectively says we can split our databases into two. The same data can be stored twice, once to optimize it for commands which change state, and the second way to optimize it for queries. And so what you effectively get is a set of command objects that operate on domain objects that generate events that are stored in a command database. And the command database is strongly consistent because obviously we want commands that will effectively be operating on the current state of the data. So a typical command would be book flight. Well, if I'm booking a flight, I want to make sure that nobody else has booked the seat that I'm booking. So you have to have a strongly consistent view of the available seats on the plane. On the other hand, if you're looking to book, I only need to see roughly that there's 50, 60 seats on the plane, because I'm going to pick one of them, and at the point that I pick that, I'm going to get offered a seat. Now, you may pre-block a seat when somebody looks to book, but that's a choice of the application. And again, that becomes one of the key events, because every time we pre-book a seat, it's not available to other customers to offer them up. And of course, you can make a statistical decision based on the seats that are available to allow a certain amount of overbooking, and we do see that happening in the airline industry. But the key thing is we've partitioned the data into a command database and a query database. And in traditional relational databases, the way you would do this is you would have a highly normalized command database, because you'd be updating different tables with different events. And of course, a highly normalized database means you're writing very small objects to a large array of tables that are fully normalized. But then the query side of your database is highly denormalized. In fact, it may just be one big table with all the columns in one table, because that's much more efficient to query and report on. And then what we have is a connector between the two that's copying data from the command database and updating the query database. This means the query database will be eventually consistent. Now, everybody gets a little bit antsy when you say your queries are going to be eventually consistent. And, we all say, I want my queries to be strongly consistent. Well, think about this. You might have a strongly consistent query on your database, but that query has to travel through your middleware, through your firewall, and probably over a mobile network into the hands of a mobile application. That's going to take, even if the database is returning queries in sub 10 milliseconds, there's something like 400 to 500 milliseconds of latency in the round trip for that query to go from the mobile phone to your database. So it's already 500 milliseconds out of date. And if you've got a high performance event-driven system, I can guarantee you new events have come in since that 500 milliseconds went by. So effectively, your queries are always going to be slightly out of date. It's your commands, the act of purchase, that's going to be the most important thing that's strongly consistent. This is what CQRS is all about. Make commands strongly consistent. Admit that your queries are always going to be eventually consistent, and plan for that in terms of building your application. And in MongoDB, we can do this. We can do this in MongoDB because we can effectively tail the op log, or in fact, in MongoDB 3.6, we have a thing called change streams. So effectively, you write your domain objects to a replica set, which effectively has a primary that replicates to two secondaries. We can take a change stream of writes off the secondary. All those writes can be replicated to another primary through a Kafka queue, and we can rewrite that schema to optimize it for querying. Or indeed, we can add indexes to the query cluster that make querying more efficient, whereas in the write object side, we don't add indexes, because guess what? Indexes double the write fan out or treble it for every index you write. It costs you another record. And instead, we basically add the indexes on the query side, where we can get very fast querying. With MongoDB, because the objects are effectively hierarchical JSON documents, we often don't change the schema that much. It's just the addition of indexes that makes the queries more efficient. And so a typical domain object event would be have an ID, a timestamp, a department, a purchase from, line items, VAT, total price, currency. But the beauty of MongoDB is if we change the event structure over time, we can add new fields. It's a dynamic schema. So although some set of fields will always be in the event source, we can add new fields. So imagine we start to take mobile orders, and those mobile orders have a geospatial location, and we want to add that to the purchase order for security and anti-fraud prevention. Well, there's no point in us going back and adding the columns or fields to all the old documents, because we don't know when those orders were taken. They were done over a network or via a line printer or indeed by the post. So one of the great things about being able to dynamically change a schema is you only change it for the objects that require it, which is all the objects going forward that take orders on mobile. If you're in a relational model, your event source is intrinsically not immutable, because when you add columns to enrich your event source with new data, you add the column to every previous transaction. And that effectively means it's not immutable. You modify every event by adding a new column, and that's dangerous. And the reason that's dangerous is because developers are dumb and do dumb things like, oh, we've got this empty column in old versions of the data. We can use that for something. And then you're in a real mess, because now you're updating the immutable objects with new information, and that is a bad idea. So much better to use a dynamic schema database like MongoDB that can add new fields without changing history. It satisfies your immutability constraints while giving you the ability to develop dynamic schema and, of course, address new business concerns and new business needs. So, in summary, event sourcing. Capture state as first-class objects. Define your application in terms of a set of commands that change state, and event captures the before and the after state. If anybody here has ever used Salesforce or worked in a Salesforce environment and worked with opportunities or contacts or leads or campaigns, one of the horrific things about Salesforce is every addition and modification to the record state erases the old record state. So there's no way of tracking how an opportunity changes through its lifetime, or a lead or a contact who changes. Like, what happens when a contact moves from one business to another? Well, we update with the old new email address, but we did throw out the old one. Now, we may have a whole bunch of communication and campaigns using that old email address. So event sourcing is here to capture state and state changes as first-class objects. CQRS speaks to us about how we build high scale. I'm just getting a chat question in here. CQRS optimizes for commands versus queries. Now, CQRS is not for everybody. If you're building the flight booking system for Kayak, you need CQRS because you're dealing with millions and millions of transactions a day. I guarantee you, for most people building most of the applications they will build in today's world, you're not going to need the firepower of CQRS. Just a good event sourcing model will get a lot of what you need to do. You need to think about CQRS for those applications where you are building for 1 million users or more. You know, you can build a perfectly good application on top of SQLite that will handle 10,000 users, right? I mean, modern databases are just amazingly performant, right? But if you want to build at a scale of hundreds of thousands to millions of live users, or IoT sensors, or self-driving cars, then you're going to need to think about something like CQRS. MongoDB is designed to build both the event store and the query store because of its dynamic schema and the ability to change the schema from one database to the next. In fact, a lot of our developers just effectively combine the CQ and RS in one cluster, and we can effectively use sharding to partition the read data, the older data, from the write data, which is the newer data coming in. We also have a storage engine model. So MongoDB comes with a variety of different storage engines. So you can use the WiredTiger storage engine, you've got an encrypted storage engine, and of course we have an in-memory storage engine. So you can use the in-memory storage engine for your commands and effectively use on-disk storage engines for your queries so that you effectively get the best of both worlds. And we come with a complete aggregation framework, which allows you to generate those snapshots you want directly inside the database. So that's event sourcing. It gives you the ability to think about your model and your data in a new way. It's designed to optimize for modern database storage engines that are basically copy and write engines that love to append data, but don't really like to update data. And we've just launched MongoDB 3.6 with 2 specific things that really make doing this kind of thing easier. One is retriable writes, where we automatically store session state between the client and the server, and will effectively make all writes idempotent regardless of failures on the server. And a change stream model, which effectively gives you a cursor into all of the writes that are happening on a current collection. So it's the perfect database for building your event sourcing applications, and you should go out and build one of those right now today. That's me, Joe Drumgoole. Thank you very much for listening. I don't know whether I'm taking questions, but I'm happy to take questions if that can be done.
Joe, you can take some questions. I'm hearing a voice in my head.
Okay. If you want to maybe take questions from the audience and shoot them into the chat box, I will answer the questions as they arrive.
No questions on this side.
Well, if that's everything, thank you very much for having me. Happy to do this again on another topic, but yeah, it was great to be here. You need to invite me to come to South Africa in the summertime. Okay, guys, I'm going to drop off here and I will see you guys soon.
Eight. How was the topic? Rate the topic. 8. How was the presentation via Zoom? 6. Obviously, you like it if somebody's in the room. Okay. Okay, sure. Any other opinions in the room? Gloria? No opinions. Okay, good. Okay, let's take a 5-minute break. And then I think we can start with Willie. How long break do you want? 5 minutes, 10 minutes? 10. 10-minute break. Okay, cool. 10 minutes. Cool. Thank you. Have a good one. Not about you. Thank you. Okay. Thank you, Willie. Take it away.
Cool. Hi, guys. My name is Willie Engelbrecht. I'm a solutions engineer for Hortonworks. I'm based here in Johannesburg. Tonight, I'm going to tell you about NiFi. NiFi was created by the NSA in the United States in 2006. It's actually called Niagara Files, so but we call it, the short name is NiFi. In 2014, they released NiFi as open source. Who would believe that? So NiFi, developed by the NSA, is released as open source. So NiFi, the NSA has a program called the Technology Transfer Program, which is an initiative of the United States government to release projects, internally developed projects, into the open source domain. One of these projects is called NiFi. And then in July 2015, it reached an Apache project. After that, the developers of NiFi created a company as usual called Onyara, and Hortonworks then purchased Onyara from them, making it a top-level Apache project. Now Hortonworks does ship an enterprise edition of NiFi called Hortonworks Dataflow, but that's not what I'm talking about tonight. Tonight we are talking about NiFi, just the open source edition. All right, so what is NiFi? NiFi is a web interface where you can program or drag and drop these components onto a canvas and in real time design flow processing. So imagine you have hundreds or thousands of source systems, little source systems, especially IoT devices. It doesn't have to be IoT devices. It could even be a big SQL database servers. But you have source systems spread around your company, servers, log files that you would like to read from the source systems, stream them through some sort of event flow processing. Perhaps you would like to merge some data, you would like to make decisions on the data, route the data, split the data, reformat the data, change it from CSV to JSON, and then write that data somewhere else. Now, because I do work for Hortonworks, a good endpoint of that would be Hadoop, but it doesn't have to be Hadoop. So you could read data from a web API, and then transform it in some way and write it to a JMS queue, as an example. But there are many, many things you can do with it. And I'll have some demos at the end. Also, a really, really cool feature is what you call data provenance. One of the things is when you write, without NiFi, if you write these little scripts to copy data from here to there, or those rsync scripts that runs with the cron, and you have hundreds of these on all of your servers, how do you know that that really ran? Right? Unless it sends you, unless you send a mail or a log somewhere else, you don't know whether those all those cron job scripts that you have spread around the place actually ran. So this is really nice with NiFi. So you can all see it in one dashboard, and you can actually use what we call the data provenance to see how the data moved around my flow processing system. So you can see this is where it started, this is what I then did with the data, I then split the data or I merged the data, and then I sent it off somewhere else. So you got this lineage, end-to-end lineage of the data as it happened and what I did with the data along the flow. All right, NiFi ships with over 240 processors, and that list keeps on growing every single version. So what is a processor? You'll see a little bit later in the demo, but everything that we can do with data, whether you read it, whether transform it, join it, or merge it, everything action you can do with data, that you would find that in a processor. Now you'll see on the slides show there's a whole host of technologies that we can work with, whether it's MongoDB or Spark or Kafka, or Listen TCP, or Listen syslog event server. You can do pretty much anything that you want in NiFi in terms of the different technologies that you probably work with already today. Right, some of the NiFi terminology is, number one, is a flow file. A flow file is an event within NiFi. So when you're reading a JSON document, when you're reading a CSV file or a log file entry, each instance of that becomes a flow file. So a flow file is the actual data plus the attributes around it. Where did you get it from? What was the file name? What was the file size? The name of the server you got it from, etc., etc. So it's the data as well as the metadata around it. Now that we call a flow file. A processor, as I explained before, so every action you can do on a flow file, whether you read it, you transform it, you write somewhere else, that would be in a processor. And on the canvas, we just drag these processors and we connect them all up and we hit go and everything happens. You'll see that in the demo. A connection is when you connect two processors, and what's really nice with the connection is if the downstream flow events is paused, or perhaps the downstream system is offline, NiFi will automatically buffer the data for you in an internal system, so that when that destination JMS queue or destination SQL server comes back online, NiFi will automatically detect that and then send the events that was buffered through. So when you run the source script on your Linux machine or on your IoT device, NiFi will just keep on buffering it internally, and it will eventually consistently deliver that message to the endpoint. All right, so here you can see a small example of NiFi canvas with some flows connected, and you can see that also in the real time we can see the stats on our flows. So how much events we have written or read, how much events we have written, the size of the data, as you read it, transform it, and write it out. I've mentioned provenance before. So provenance gives you that history, that lineage of the data as it moves through your flow event system, as well as what you have done to the data along the way. Perhaps you have split it up, maybe you have enriched it in some form of way, maybe you've cloned it or merged it. Provenance will show you exactly what you've done with the data along the flow. So here is a really cool screenshot of of an example of provenance. So, for example, we have received data from some sort of source system, then we've modified attributes on that flow file, then we did a fork of the flow file. So we actually made like a copy. We're now doing two things with it. On the one side, we've then forked it again. And maybe we made a decision, something around that data that said, no, I'm not really interested in data with a value of less than some value. But on the other hand, maybe I'm interested with values that matches some sort of pattern, and then I do something else with it. So with every single event that flows through my NiFi, I can look at the provenance and see the exact history, what happened to that data in the past. All right, so here is another flow example, a little bit more complex. Again, what you see over here are individual processors, and they are connected, and then eventually they'll flow somewhere else. I'll show you in the demo. We also have something called MiniFi. So MiniFi is basically NiFi minus the web interface, so minus the graphical builder. So you get it in a Java or C++ program, and what you want is you want to put MiniFi on your edge devices, running your processors, and that continuously streams data back into regional clusters and maybe into a central cluster. And what's really, really cool with NiFi is NiFi, the master instance, is able to communicate back to the MiniFi agent on your source device. So whether that source device is a fridge, a till point, your car, your cell phone, there are even libraries available for Android and iPhone. So NiFi is actually able to communicate back to the MiniFi agent and tell it, no, you're sending me too much data, or hey, you send me an error. Can you send me everything around that, log entries around that error as well? All right, so just showing you that MiniFi is pretty much just a stripped-down version of NiFi. All right, again, why would you want MiniFi, and as opposed to just an agent that reads data and sends it to you? With MiniFi, you have your full lineage. You can do back pressure. So if MiniFi is sending too much data for you, you can tell MiniFi, hold on, you're sending too much data. Just send me the error logs. I'm not interested in the event normal info logs. Again, that communication. All right, demo time. Now I have documented everything I've done tonight on GitHub. So just go to GitHub. You don't have to take down the whole URL. Just go to GitHub and search for FreeBeer24, and you'll see exactly what I'm going to be demoing for you right now. All right, so when you do browse to NiFi, it's really simple to install. You just download NiFi from the Apache project page. You extract the tar file, and you run run.sh with start, and it boots up into port 9090. No, this one is port 8080/NiFi. And then you're presented with this screen. Now, by default, when you do browse it, you're going to get a blank screen, and that's it. All right? But let's build some flows. So I've got a couple of demos that I'm going to show to you. So when you drag your processors, or when you want to build a flow, you're going to be dragging a processor from your canvas here, where it says processor. And you'll see this one has got 242 lists of processors of things you could do with data, source data, transform data, and then push it out somewhere else. Now the point of tonight is not that it's a course and I'll show you each and every single processor, but you can see that this is quite an extensive list of what you could do. You could delete objects. I saw quite a few for AWS. So here's all the processors that could do things on AWS. The get S3, put S3, and so forth. Let's see. Let's scroll down. Execute. So what I do want to use is I want to use get FTP. All right. So I want to take the get FTP. At the same time, I'm going to do a get file. All right. So what I want to do is I want to take some data from an FTP server on the internet. I'm going to take some data on my local machine using get file. I'm then going to merge the two data sets together to create one new flow file, all right? With that, I'm going to then write it over the internet to another server using SFTP. At the same time, I'm going to also write that data to a database, all right? No coding required. So let me show you. All right, so we know we got get FTP, but I need to configure it with the server details. All right, so let me just grab some data here, all right? So the first server is this one. Okay, the username is Billy. Password. All right, that's it. Oh wait, I do want to change one property, just so to make it faster. Every 2 seconds. This one I'm going to say, all right, so get file will run on my local machine. It's going to be any directory on my local machine. In my case, it's called /input. Okay. All right, so now I want the merge content processor. So basically, I'm going to take whatever this thing generates and whatever that thing generates, and I'm going to create one new file out of that. So it's as simple as connecting the boxes. Okay. Good. Now I'm just confirming everything. And just to show you, I'm then going to put SFTP it to another server. The merged content. But we want to say, you know what, I'm not interested in those ones. And then an interesting feature, I can loop it back to itself. All right, why do you want to do that? Maybe the destination SSH server is down. So NiFile will queue it internally, and then whenever that destination endpoint comes back online, whether it's an SSH server, a SQL server, doesn't matter. Whenever that destination point comes back online, NiFile will then just, from its internal queue, write it back out. I just want to check. Okay, I need to put in the values. All right, so this is another server that I have. Username is Bob, and the password is also Vinny. What do we have here? We don't care about this one, as well as the original. I just want to make the scheduling a little bit slower. All right, so this is a basic flow. All right, so I'm going to grab some files from 2 different servers, merge the content, write it back to another server. So let me show you the values. So let me start with this one. Input. So remember, we configured /input on my local machine as a source system. Okay, hold on. Like that, right? All right, so I'm just going to create a file here called infile. You can see it's looks a little bit like a CSV file, but we've got some content. I'm going to connect to the second machine, and then just change to the Billy user. So now I got the second file, FTP file. So remember, I'm going to be reading both of these files and then merging them. So let's look on our flow. So if we go back to our flow, if we do get FTP and get file, we hit the play button. We'll now see that the icon changes into green. If we hit refresh. So now, because the merge content processor is not yet running, because of the red the square icon, NiFi is actually queuing the event in its internal queue, and it'll keep it in that state for a period of time, like a changeable, configurable period of time. The default is 7 days. So it's going to keep it into that queue until the next component or the destination system comes back online, and then NiFi will stream it to the next endpoint. But before I hit play on merged content, I actually want to show you the content of the data that I read. So you can actually inspect that queue. So you can say list queue. You can go into that queue and view the data that's currently being queued. And you can view the content. So you can actually see, yeah, NiFi rocks. All right? And if you go to the other queue, and inspect that content, we will see that, hey, it says FreeBeer is cool. Now that kind of matches the two files that we were reading. So what we do now is, now we hit play on merge content processor, play button, and it's going to do its thing, and obviously put SFTP is not yet running, so it's just queuing the data here. Wait, before I continue, let me connect to the third machine. I want to change to the BOP user. So remember, this is the BOP user. SU BOP, just to prove, just to prove that there are no files currently in the BOP user. So let me go back to NiFi, and I can start put SFTP. But before I do that, I actually want to show you now I've now merged the two files together. So we've now created a new flow file with new content, which is the merge content. All right, if you say view, we've now merged the two flow files together. I think the sound is still working. Okay, yeah. All right, and then we hit play here, and we can see from our stats that it received one event, and it wrote that event down to the file system. So in real time, I can build a flow. I can see the statistics. I can see the data of each flow file as it's flowing around. I can also see the provenance. In this case, the provenance isn't really cool looking, but I can show it to you. So we know that there is one event, and I can show the provenance to you. It's basically just join the data and then put it on the file system. Okay, let's look at Bob. Does Bob have the data? Yes, he's got the data. What's the contents of that? Well, we will expect it's 2 lines, right? And yeah, that's the merged data. Simple as that. Yeah, isn't that cool? Yeah, how easy was that? All right, but you want to tail this file? No. So what NiFi will do is every time there's an event, it's going to make a new file. But I'll show you another file. I'll show you another demo where I am going to tail a file. That's even cooler. All right. All right. So I'm going to do something else. I'm going to modify this flow. Before I do that, I want to log on to my database. Just check that it's empty. Oops, no, let's just clean that one out. All right, so I've got a table in my database called FreeBeer. I am now going to do the same thing again, but this time I'm also going to be writing that same merged content into my database, right? No SQL required. You do not need to know how to write SQL statements. So what we do is we drag another component called put database record. Yep, there we go. Connect the same merge component in. Just tell it that we're not interested in those ones. Okay. All right, so we just need to tell it, okay, what kind of data am I streaming in? Is it CSV? Is it JSON? You just create like a JSON service, so then it will just, the record processor will automatically understand the JSON data and convert it into rows and columns for you, but I'm going to be using the CSV reader. It's going to be an insert, and it's going to use my predefined MySQL connection pool, and the table name is FreeBeer. All right. Cool. So I can actually hit play on this. Now I can recreate those files on the Linux file system by echoing that, or I can use the awesome feature of provenance. So let me show you. So we can actually go back to view data provenance, and I can go back to this event. Okay. I can go to this this event, and I can, no wait, I'm not trying the right one here. I can replay this provenance event, all right? And that's really cool. So as I develop my NiFi flows, I can replay the same event over and over until I've kind of fixed or built the flow and fixed it into the way that I want it to be. Or naturally, you can regenerate those source files, but it's not always possible to regenerate the same source file. You can't ask the thermostat on your fridge to send the temperature of 5 minutes ago, right? It can only tell you the temperature now. So with provenance, you can replay those same events. So I'm just going to replay the event. All right. Let's give it a second. And magically, we have now written a record to the database. So if we go back to the database and we select from free beer, we will see, well, just one row. That's not cool. So let's truncate it. I'm going to do the whole event. No, I do exist. Oh wait, this is the slash input. No, I can just do this one. And I can do this one. Okay. No, I don't want to truncate. All right, cool. So there's my merge file, and it's written both entries to the database. To the database. How cool is that? All right, so that's just an introductory demo. Let's take it up a notch. All right, I've got Twitter. I want to read tweets from Twitter, and actually what I want you to do, for those of you who are using Twitter, I would like you to tweet something to a hashtag freebeer. Let me just get you the name. It's freebeer sessions. So over there, if you can tweet something to freebeer sessions, that would be really, really cool. But wait a minute before we do that. I'll tell you when to do that. But send something to freebeer sessions. All right, so what I have here is I've pre-configured my get Twitter processor. And the reason is because I don't want to be sharing publicly on video and everything, my secret key and my access key and everything. So I just pre-configured the Twitter one. And I have also pre-configured the put Slack. So what I'm going to be doing is I'm going to be reading from Twitter. Twitter generates this massive JSON structure file for you. I'm not interested in the whole thing. I'm just really interested in two elements within that JSON document. One is the actual message, and the other one is who sent it. All right. So be careful what you do send. I'm gonna be using your name in the Slack. All right. So I'm not going to connect the two directly. That's not what I want to do. I do need to put something in the middle, and that would be evaluate JSON path. Okay, so let me connect it up here and hit play. All right, we got one tweet. Ew. But it might not be for free beer. It might be for something else, because I also got all kinds of Hadoop and big data. Yeah. Wait. Let me just take those ones out. Take all of these ones out. Only the free beer ones. Wait. Come on. Okay, I'm just gonna. Sure, I'm getting a lot of tweets here. Sweet. Okay, so if we view the queue again, so let's look at what Twitter sends back to you when you do an API call. So let's take one of the big ones here. All right, so here's what Twitter will send back to you. Let me just format it. So when you tweet and you call the API will send you back all of this information. Now, I'm not interested in every single thing. I'm just interested in two things. One is the text. Yeah, there we go. Free beer is cool with Villingra. Sweet, thank you. You're cool. And the other one is the username, I think, screen name. Free beer session. I think that's Angela tweeting this. So I'm really only interested in text as well as screen name. So what I'm going to do is I'm going to take this JSON document and strip out the information that I want, and then use that information and flow that further in my flow. The rest I'm just going to chuck away. So let me show you how you do that. All right. So what we're going to do is we're going to create 2 new attributes. So in my flow file, I'm going to add additional attributes. So an attribute could be where does the file come from, its file name, its size, etc. But I'm going to add additional attributes, being the message as well as the user that sent it. So let me show you how to do that. So we're going to say, I just want to copy here an attribute called Twitter handle with the value of screen name. Now remember, when I showed you that JSON document, it was under a user and then a subsection called screen name. So this is the way you format it. So you say $dot being the referencing the JSON document, and then you just specify the path into the JSON document, the value that you're looking for. And then the other one was Twitter message, another attribute, with the value of .text, because that was a high level entry. Excellent. So let's connect the 2 together. Wait, where are you going? Let's connect the 2 together with the match entries. And I'm going to hit, what are we, exactly 1. So we want to add it to the attributes. Are you happy? Yeah, because it's just those 2. Failure and unmatched. All right, so let's hit play here, and then we're going to say go for it. And obviously, we expect it to queue over here because my put Slack is not running yet. So let's look at what it stripped out. We can say let's queue. And we can see some of the tweets. Wait, that's not what I want to view. It's now attributes. So we now have the attribute of Cakehouse Beer on tap for the Twitter message, as well as the Twitter handle was Cakehouse Brewery. So some free advertising there going on. Okay, let's connect one thing in my, and I don't actually have to configure it. So in my put Slack, what I'm doing is the webhook URL I've already set. Again, that's a sensitive value. I don't want to do it in the demo. But the webhook text is something that I define. So I can say at free beer, 24 here at Investec, user the set. So that Twitter handle is the attribute that I generated in my previous, as well as the Twitter message. So that's how I reference it. Okay. To show you into my Slack, currently the channel free beer is empty. And what we expect is if I start that put Slack processor, it's going to grab whatever in the queue and just pump it into my Slack. Okay, so let's start this thing. All right, it's writing to Slack. And we can see how many events it's writing to Slack. And because Slack seems to be a little bit slow, this queue is not emptying really, really fast. But NiFi is sensitive enough or clever enough that it'll push it as far as the destination system can accept it and just hold back on the rest. So it's not just going to dump everything on Slack or your endpoint. It's going to send it as fast as that system can handle it. All right, I've got 17 tweets. Here we go. Cool, eh? So this is more than just tweets. You could do anything. So imagine if it's email messages or any event in your company. Alert. So if a temperature on a fridge is too high, or if a purchase came down that you think is fraud, anything you can send it to Slack. It doesn't have to be tweets. I'm just using the JSON as an example. Sweet. Thank you, guys. All right. Now, I'm not done yet. No. Let's up the ante a little bit. So now what I'm going to do now is I'm going to tail the log file of my Linux machine. There we go. There's your tail thing. All right, so I'm going to be tailing the varlog secure file of my machine. So the varlog secure file, if you don't know, is the log file on my machine that basically tracks who's trying to connect to my machine successfully or unsuccessfully on SSH on an SSH level. So every time you connect, whether it's successful or not, varlog secure will print that into a log file. So what I want to do is I want to get all the events that for failure, and I want to grab that IP address. All right, so let's start with that. So we do a tail file. Okay. Yeah, it's a single file. We var log secure. Okay. So what I do need to do with it is I need to split it, because it's going to now read this whole file as a single event. I do need to split this file into individual lines. So I need to split the file into individual lines, split content. Okay. Come on. Thank you. Yeah, that should be fine. Once I've splitted the file into individual lines, I'm now looking for lines matching failures. I'm not really interested in successful connections. I'm really only interested in the failure ones. So what you can kind of imagine in your head happening here is you're actually cutting that file, and then you're grepping for failure, and then you're grepping for something else, and maybe you're doing an awk statement with it. So if you understand that flow on a Linux command line, that's kind of what we're doing here in NiFi. You're building this event, the streamed event, by doing little actions on the flow along the way. So I need to look for replace, I think it's replace text. Let me configure it. I need to look for messages or lines that matches failed password 4. So the regular expression looks like that. Okay. For the splits. And I'm not interested in the original anymore. So I'm looking for lines that matches failed passwords 4. Once I have that line, I want to do another thing. I'm now looking for just the IP address in that line. I'm not interested in the text. I'm just looking for the IP address. Again, you use replace text. Let's configure it with this statement here. So that is a regular expression that will find just the IP address and bring out the IP address to you, so basically splitting everything else off of the message. Now we'll view the provenance. We'll view it in a second to see that it only brings in an IP address. The only tricky thing with this demo is I actually need someone to log onto my machine and fail. I do have it running on another screen. Byte sequence. Wait. Is text. Wait, that's it. What's going on here? So I'm just going to cheat a little bit. Look at my crypt notes. No, wait. Wait. This is split text, not split content. Okay. Wait, I made a mistake here. Let me just delete these two ones. Split text. This one checks split on every line. That looks fine to me. Wait, need to send it on. Yeah, no, wait, the splits. Nah, damn it. Okay, and I've configured that one. Yeah, for success. Yeah. Alright, I'm just temporarily going to add this little sneaky thing in here so we can see what comes out the other end. Success. Need to failure. As well as failure. Solid. So this one is quite a lot of configuration to get right, but it's quite impressive what happens in the end. So let me hit tail file here. Actually, that was really cool. Someone is already trying to get into my machine. So we're just hitting start here. So what I want to get to the end, and I want to see that at the end, I actually have, I know what happened here. It reread that whole file, so which is cool. Demo's going to work. So let's just check that right now, what's in my flow file is only an IP address. So if we look at, it should create, it should be creating a value. Oh, sorry, we can view it. No, wait, that's not going to run. That's not the content. I just want to change this one here. So I do need to stop it. Evaluation. Yeah, that looks fine. Should be working. And here. Hit play. So what I'm going to do is I'm going to tell it to reset state. Should clear the state. Hello. Oh, I can't do it if it's running. So that it can reread the file from the beginning again. Because it'll actually remember where it was at where it was last at. Let's just check the queue again. I'm a little bit worried about what it's doing here. No, it's not. Sorry. It's not doing what it's supposed to. All right, so I'm going to go to my cheat mode and show you the pre-built one. I'm going to spend all night on it. So, all right, so we split the file into individual lines. We're going to extract the lines that says failed password 4. Then we're going to extract just the IP address out of that, at which point we send it to a new processor called GeoEnrich IP. It's a special processor, and what you do is you point the processor to a database file that you can download from the internet. You get free ones that's updated like once a month, and you get paid for ones that's updated every day. This is just a free one. And what we want to do is we want to send the IP address to the GeoEnrich processor, and in return, it's going to send me back the longitude, the latitude, the country, the city, the town name, where this IP address probably belongs to. And I'm interested in the country as well as the city names and the longitude and latitude. Actually, no. It's gonna enrich the flow file with additional properties, like I said, country, city, longitude, and latitude. All right. So once it does generate those attributes for you, I can now manually construct a new JSON document. And the reason why I'm doing a JSON document specifically is because I'm going to be in the next step, I'm going to be writing that to an Elasticsearch index. So in my case, I want to say location consists of a latitude and a longitude with these attributes that are referenced from the previous processor, as well as a timestamp. Although in this case, timestamp is not really needed, but I just want to track it when it happened in any case. So a timestamp when somebody was trying to get into my machine. So I'm generating a new XML document, which I am sending to an Elasticsearch index. So in this case, it's called important locations, but again, you can call it anything else. If my actual demo worked, I would have ran this command for you where I just create an Elasticsearch engine. I will run it for you, but I don't really need it, just to show you that it does work. Oh, that doesn't even work. I think it already exists. Okay, so the index already exists. All right, so it's written to an Elasticsearch index. All right, so every time I'm recording, there's an event, I'm recording the longitude, the latitude to my Elasticsearch. Now, what I'm now going to do is I'm going to go to my Kibana. I'm going to say create a visualization, which is a world map. I've pre-created my index in Kibana. I'm just going to select it. I'm going to say use geo coordinates, so the longitude and the latitude. I'm going to select the column, which is called location, and then I hit play, and I can see all the systems around the world trying to connect to my machine. Now, the bigger the dot, the higher the count. So we can see some big dots here, the usual suspects. All right, a couple here in South Korea. Oddly, nothing in North Korea, but I do have a few in Beijing. It looks like it, and yeah, just pretty much spread around the world. Okay, and yeah, maybe some in Paris as well. All right, so that's the second last demo. Now I'm going to show you the coolest demo of them all, which is a Bitcoin demo. So we all play with Bitcoin, and I want to show you how you can actually track Bitcoin data in real time and then graph it using, in this case, Grafana. So, and this is an easy demo to build. Okay, so let's go to the last one. So most of the Bitcoin exchanges allow you to query their trading data in real time, and it spits out for free, and it spits out a JSON document. So you can actually just browse to the Bitcoin, in this case the Bitstamp URL, and it's going to spit out a JSON document for you. All right? JSON is really, really easy to work with in NiFi. So let me show you. So we do get HTTP, and we want to put in that URL. Let me just grab that URL again. Okay. So you just give it a URL. I would need to give it a file name. I'm going to call it freebeer quotes. All right, I need to use an SSL context. Because I am connecting to an SSL endpoint, I do need to trust that certificate first as a security measure. So the certificate of Bitstamp, I do need to trust that. In this case, I do not need to pass usernames and passwords and anything like that, additional header information. You could if you do need to, but with this API endpoint, you can just do it directly. So we are happy here. Now, I am getting this JSON document. Again, I'm not interested in all the data. I'm just interested, as the demo, in two elements. One is the last value, the last time, or the last value of the transaction, as well as when the last transaction happened, so that I can plot it over time. So what we do is we use another processor, which is JSON. Let me just get, it's not that one, it's Jolt transform. So I actually want to transform this JSON document into a simpler structure. So what we do is we connect them up, and then we just say, all right, so what we want to do is when we want to take this input JSON document, we go to the advanced section, just plug it here. Come on. All right, so we want to say timestamp must be rewritten as timestamp, and last must be rewritten as last. That should do it. No, it's not a chain, it is a shift, hit transform. All right. So now I've created a new JSON document that consists of only the two elements, the timestamp and the last value. I've split out everything else. So I want to take this Jolt specification and save it in my processor, which is down here. Remember to set it to shift. Okay. And then easy, really, really easy, we're going to write this to Elasticsearch database, which I think probably already exists, but we'll confirm in a moment. Let's just configure the Elasticsearch, which is this one over here. I don't have to configure any of those, but I do need to configure these three values. I know out of my head is UUID. It's this horrible format over here. Because in my case, my Elasticsearch is actually set up to create an index for every single day. It makes it easier to drop indexes if they're older than 30 days. Otherwise, I have just a static index name, and it's really difficult to delete data out of this index. Whereas if I have an index for every single day, after 30 days, I can just say drop the oldest one. So that's why I have this convention where I point to an index with a date format, which is this. And then I just need to specify, this value here for types. Let me just confirm whether that index exists or not. If it already exists, that's cool. Oh, no, it didn't exist. So I just created the index. And wait, no, that's the wrong one. That's my mail. Okay, let's hit start. Failure and success is fine. We just reroute that for retry again. So if my Elasticsearch is down, I'm doing maintenance on it and so forth, NiFi will queue it and then just rewrite it back in once I start it up. I need to, not interested in failures. Okay, let's hit play here. So I'm just gonna hit play on the first two because what I wanna do is I wanna see, I just wanna confirm that I'm generating the right JSON output. So if you hit view, yep, it looks good, awesome. It's gonna match my index. So we can switch it on. All right, so that's now happening every second in real time. It's just writing the last trade value into my Elasticsearch engine. I'm now going to use Grafana, create a data source that points to this Elasticsearch, and then create a dashboard on top of this data source, and then show you the data that I'm graphing in real time. So let's go to data sources. We say add data source. We call this free beer, and we know that it is Elasticsearch. Okay. Index name is index name is this one here. And the timestamp, just take the at out, say add. All right, let's just test that. Yep, looks good. I can connect to it. All right, let's create a new dashboard. New dashboard. All right, graph. Edit that out. We're not interested in this one. It's kind of like a default, just to show you that it's graphing some random values. But we do want to go to the free beer data source. I want to say add query. Let's do the average on the last trade. Timestamp is every 1 second. And if we are lucky, let's do 10 seconds. Oh wait, I know what's going on. I need to just configure that it's connected. Go back to 1 second. It should be graphing. Am I writing to the right one? Yeah, right. Free beer quotes. I just need to double check. Yeah, this looks fine. It should be writing. So it's supposed to be generating the graph here on the right hand side. I am taking, yeah, that's right, that's weird. No, it's not generating anything. Well, what you do want to see is you want to see your dashboard look, let me just say that. You want to see something that looks like this. All right. So I'm actually tracking many Bitcoin exchanges in real time. One of being Luno, Bitstamp, CEX, IO in real time, and then I'm graphing it. This is just a project hobby of mine. So if I show you how that flow looks like, it's a little bit more complex. So if you go to Bitcoin currency, so this is me tracking various Bitcoin exchanges in real time. So that's kind of what you can do. All right, any questions? blown away, are you? Right?
Speechless.
Isn't this cool? So remember, you can do everything I did tonight by going to my GitHub repository. Just search for FreeBeer24. All the instructions are there. How to set up NiFi, how to set up Elasticsearch, Grafana. I've got all their template XML files for you that you can just import. You just have to fill in a couple of values like your Twitter keys and sensitive keys. Hit play, and then you'll get the same demo on your end. Cool. Thank you.
Thank you, Willie. Yeah. Hit play and pray. Anyway, thank you for joining us tonight. There's still food out there. Grab yourself some drinks, network a little bit, give somebody a hug, kiss even, maybe even a little bit, and then drive home safely. Thank you very much, and have a good year.